5 times 5 is?
25.
Yeah. Hey folks, welcome out here to TN Learn Mathline Summer School. We are so glad you've tuned in this afternoon. I am your host, Ernie Roberts, and this is TN Learn Mathline Summer School style. Now some of you are starting to go like, wait, I start school next Monday, or I already started this Monday, or I'm going to start in 2 Mondays, or I'm going to, oh my goodness, it's almost over, isn't it? Summer is passing us by. But we're getting you ready. We're hopefully getting you ready to go back and do a little bit of math for your classes this fall. And fall is August. Some of you it's July. My goodness, it's crazy, isn't it? But let's take a look at where we're going to go today. We've got some exciting stuff going on for you here. And we're going to go on the road with L&N STEM Academy today. Now, they've got a few of their folks work with us on our Smoky Mountain Media Group, and they're going to be helping us out with some questions. We're looking at algebra problems today and applications of those algebra problems to some real-world situations. So, going to have some fun with it. You may want to get a pencil, paper, calculator maybe, but other than that, hey, let's sit back, relax. Don't call in because we aren't here to answer, but we are sure glad you have tuned in. So let's take a look at our first problem we've got going today. First of all, we're going to go back and do just a little review here. Solve and check. Notice 2 parts of this. We're going to solve the equation. Then we're going to go checking it. And to solve it, remember our goal is to get y by its lonesome there, to get it all by itself, all right? Now, to do that, I've got a -5 that needs to be taken care of. That's a subtraction moment there, so we're going to have to do the opposite, which means we're going to have to add to get rid of it. Also, we've got this 2/3, and some of you go, ooh, we don't like fractions. Well, I understand that, but we're going to work around it. We're going to have a way to get out of this one, all right? And hopefully our answer comes out fairly decent, so when we check, it won't be difficult, right? You got it? So let's take a look at our first problem. As I mentioned in looking through this thing, we are going to add 5 to both sides because that is how we undo the subtraction. It's how we reverse that process. They're inverse operations, so what we need to do, since it says subtract 5, we're going to have to remove it by adding 5. Now remember addition property of equality moment? Oh, we love those properties, don't we? But those properties remind us that we have to also add 5 over there to the 7. Both sides. What do you do to the left? You got to do it to the right. Addition, property of equality, perhaps subtraction, but we aren't subtracting here, or multiplication, all the good things. This is all about addition. So let's see, we've got 2/3. Have a big Y here. Over here, I now have 12, because that's what happens when you add, 7 plus 5. Y'all got it? You got it. Now, I have to clean up, that 2/3. This is where we start going like, we don't like fractions. What we've got to do to remove this, basically we're going to divide 2/3 into 12. That's what this is saying. It says 2/3 times a number gives us 12. So to undo that multiplication, we need to divide. So we're going to divide by 2/3. You said, Ernie, that sounds worse than before. But you know what? It's true. It does sound bad, doesn't it? But what we're going to do is use the reciprocal, because when we divide by 2/3, it's the same thing as multiplying by 3/2. So we're going to use 3/2 to clean this thing up and multiply. And you know what we're going to do also? We're going to go right over here and do it to the right side. Multiplication, property of equality, at your command and service here, all right? And let's see where it takes us. Let's see where it takes us. 3's cancel. By the way, they don't cancel to zeros. They leave us 1s. 2's cancel over here. That's why we chose 3/2, because cleans up that fraction beautifully. Now some of you are probably saying, Ernie, could we have gone ahead and multiplied by 3 and left the 2 alone for a while? Yes, you could do that. That would give you 2y equals 36. That's another option. I just want to clean up the whole fraction while we're at it, okay? And that's what I'm going to go with here. So we got y equaling, looks like, well, we could say 36 over 2, or we could play the game. How about it? 2 goes into 12 6 times, leaving me with 18. There's your final answer. Is it a good one? Let's find out. Let's check, all right? So over here to the side, we're going to say 2/3 times 18. We're going to subtract our 5 and hopefully come up with a 7. That's the goal. That's our goal, all right? Let's see what happens. Let's see what happens. Oh, 2/3 of 18. Some of you have already got that in your head. Let's put a 1 underneath that for some of us who like to play with the fractions in this way. We can say 3 goes into 18. How about it? 6 times. 2 times 6 gives us 12. There you are. Subtract your 5, subtract that 5. Does it give us 7? Check it out. It certainly does, because if you take 5 from 12, you have 7. Checks, checks, life is good. So we did it, we solved, we checked, we conquered, all right? First problem down the way, all right? So let's go ahead and let's play with some more, all right? We've got some good stuff coming up here today on Mathline. By the way, reminder, it's not a call-in show today, so please don't try to call us. We aren't going to be answering. But we are going to be working with some great equations here, so get the pencil and paper and play along with us, all right? Speaking of which, let's take a look at our second problem on our list here, all right? It says solve and check. And we've got 2y minus 1. Let's go ahead and give you all a chance to write that down at home, all right? 2y minus 1. And notice it's all over 5. It's the whole quantity. It's almost like it's not like there is, in your mind, there could be a parenthesis around 2y minus 1. But it's all a quantity divided by 5. Notice I said divided by 5. Some of you say, well, does that mean over? It means divided by, all right? And it does also pass as being over, all right? So we put a 7 right there. It's in the numerator. I can place a 1 underneath here. It might be helpful. It may not be necessary, but sometimes we like to see fractions matching out on both sides, all right? Now, from here, we're going to take care of that. Remember, call it division. We're going to take care of the division. So we're going to multiply both sides by 5. Notice I said both sides. Multiplication property of equality running your way there. And notice these 5s will cancel. Now, some people always ask, well, could we have written 2/5 y minus 1/5? Well, you could, but you wouldn't want to because that looks messier than what we got, all right? And by the way, we just lost the 5s. We just lost all semblance of fractions here. I love this now. It's 2y minus 1. You've got 35. 35 hanging out over there. Easy, easy, easy. Oh, yes, it's easy at this point. Let's do it. Let's add 1. You know the drill. We're going to add 1 to both sides. Go play the addition property of equality, right? And we got 2y equaling, add them, we get 36. Even numbers, we know 2 will divide into that evenly. How about it? Y equaling to 18. Hope, hope, hope it's good. All right, you're all going like, that's what I got at home. I hope that's what you're saying, all right? Let's check and see. And the key word is let's check. So let's go back to our original, which is a 2y minus 1 all over 5. And we're hoping that once we put in 18 for y, we are going to be able to get 7. That's our check, all right? So we have solved. Now we got to check. So let's see. Put that 18 in there. So it'd be 2 times 18 minus 1. Remember, we've got to work that numerator out first. We've got to take care of the top of that fraction. Keep the 5. It's not going anywhere. And keep our 7. It's hopefully going to be our final answer on the left-hand side, too. All right, I'm going to multiply. I'm getting 36 minus 1 all over 5 equaling to 7. Ha ha! Guess what we get? 35 over 5 equals 7. My dear friends, those are one and the same. They do check out. You get 7, 7, 7, oh, 7 all the way around. Lucky 7s today on T and Learn Mathline. So 18 is good, and our check works also. So that's what we're about today. We're going to now take some of these equations, a little bit of review time for you. Hope they went well and smooth and easy. Now we're going to do a little application. Ooh, we love application. In other words, we're going to have story problems. But we want to give a good credit to our Smoky Mountain Media Group, and the L&N STEM students who are part of that group here at PBS are going to join us here. So come on out, guys, and let's see what we've got going here on the road with L&N STEM.
Got a math question? Mathline has answers. Hey, Mathline.
My name's Jake, and I'm from the L&N STEM Academy. A Mathline ad takes up 1/4 sheet of paper. How many ads can be made with 20 sheets of paper?
Jake, thank you. We are going to answer that question here in just a second. Let's read it, make sure everybody's got a chance, and you can make a few notes of what's the important pieces. It says here a Mathline ad will take up 1/4 sheet of paper. How many ads can be made with 20 sheets of paper? All right, now we're going to assume that each of those ads are a 1/4 page, all right? And hopefully we can draw them correctly here on the page. Let's see what we've got going on here. Let's see the picture of this problem, all right? Got a little sheet of paper here with a little green, pretty color, I guess. And let's see what happens when we draw and divide this thing into basically quarters, all right? So there we go. There's a horizontal look. And let's find a vertical look here. That looks about right. There we go. We got nice 4 pieces. A little crooked there, but we're okay. We'll call it a fourth, a fourth, a fourth, and a fourth, because that is what we've done, all right? So we're going to take, and we want to figure out how many of these 1/4 pieces will we have if we start out with 20 sheets of paper, all right? So let's think about it. We're using 1/4, and we're going to call n, 1/4 of n. N is ads, okay? 1/4 times the number of ads, and that's going to tell us how many sheets of paper we are going to need. Does that make sense to everybody out there? Let's talk it one more time. In other words, n, what are we looking for? How many ads? So each of these counts as an ad. So this is an ad, this is an ad, this is an ad. So each of these is an n, an n, and an n, all right? So what we're going to do, we're going to take that 1/4 of n, and we're going to take care of that. We want to find out how many of those, if we take a 1/4 of that number, how many we get to 20. Now let me caution you something here. You do not want to divide 4 into 20. That's not the game plan here. Remember what we did a minute ago? We have to divide. We have to divide by 1/4, which means multiplying by the reciprocal, right? So it's going to be 4 over 1 that's going to go through there. So look what happens. Look what happens here. We're going to multiply both sides, multiplication, property of equality coming our way, by 4. And the 4s say goodbye. The n stays around. And over here we get 80. So how many ads can we get? We get 80 from the 20 sheets of paper. And that's, wait, and does that make sense? Well, here's 4. And if I drew 20 more sheets of paper out there, it'd be just like saying 20 times 4, wouldn't it? So that's our deal. That's our deal. Sometimes when we think of fractions, we get a little nervous, but when we use a reciprocal in this case, all of a sudden it's not like dividing by 1/4 anymore. It's doing what? Multiplying by 4. Multiplying by 4. And that leads you to a sweet answer of 80. And by the way, our n, remember, represented what? The number of ads that you can get. So that's what's going on there. That's what's going on, all right? 1/4 sheet of paper basically means you get 4 ads per sheet. You've got 20 of them. So 4 times 20 gives you 80. Check it. It works well, doesn't it? Should make sense. Should make sense. So let's see. Thank you, Jake, on that question. Let's get a little, take it a little more advanced even here, all right? Let's take a look at this next problem I've got here on paper. And it says, Javier is fixing computers for a rate of $75 per hour. Folks, that's good business. That's good money, all right? He gets a $40 travel fee. I don't know how far he traveled, but maybe he was on the road for a while, all right? But anyway, we're going to take Javier and his billing for, he gave you a bill of $340. How many hours did he work for that, all right? So in your mind, I want you to start thinking, what are we trying to figure out? Let's go ahead and first of all let H equal the number of hours. We always like to define a variable when we're looking at a word problem so we can remember, what are we trying to find out, all right? We're trying to find out how many hours. Now, he worked $75 per hour. That is of importance right there. And it says plus. That tells me, we're not taking away, are we, folks? We're going to add that to his bill, all right? You know that's like adding tax and tip at a restaurant or in a business or anything. You got to have these little extras here. This is what's going on here. He is billing you $340 for his work, all right? So let's see what's happening. We're going $75 per hour. That's a good way. Per means multiply, all right? So 75 per hour, not miles per hour, but dollars, all right? So $75 per hour. Add on more money. Oh yeah, he's going to charge you $40 because he had to get to you. And then we come out with $340. All this is money. Money plus money gives you the total amount you owe Javier, all right? So Javier, let's hang on to this. We're going to move the 40 out of the picture, subtract it out, and we're going to end up with 75H, which means $70 per hour, $75 per hour. Over here, we're ending up with 300. And now it's time for us to drop the bottom out and also drop a 75 on both sides, all right? So we're going to divide by 75 both sides. And you know what? You're going to get 4 hours. Now, proof in the pudding. Does it work? Or proof in the hours here, I guess, would be the cost. Or the money. We're going to check the money. How about that? Let's go with it. 75 times, some of you are going, what in the heck is proof in the pudding? That's an old expression. And yes, I'm old. So we're going to take and add 40, and we're going to get 340 out of that, all right? And we're going to say, hopefully we do. Well, 75 times 4, that does get me back up to $300. He's adding $40 for his travel. My friends, it looks to me like a good old $340 equaling $340. That's what you owe Javier, and that's how long he worked. All right, good stuff. Way to go. Thank you, guys. All right, let's take a look at our next view. And Ellen in STEM back with us on this one. See what you got for me.
My name's Zach, and I'm from the Ellen STEM Academy, and I have a math question. If I had a friend who paid a landlord a $500 security deposit and 2 months of rent for a total of $1,900, what was his rent for 1 month?
All right. Zach has a friend who paid a landlord a $500 security deposit and 2 months rent for a total of $1,900. What is his rent for a month? All right. I changed the words just a little bit. Sorry, Zach, I didn't mean to do that to you, but I've got Jenna and her landlord, and this would be her rent, but just so everybody doesn't go like, we got all shook up about it. But so let's take a look at this problem, all right? Let's take a look at this one here. Again, very straightforward problem. And like I said, I brought Jenna along for the ride on this one. That's okay. We appreciate it. Thank you, Zach, for helping us out on that. The problem is the gist here, all right? Landlord, a $500 deposit and rent. All right, now, dear friends, when you all go out and start to rent an apartment, a condominium, or a house, you've got to usually put a deposit down of some sort, a damage deposit. If you are good to that home or good to that apartment, you'll get it back, all right? But then you also are usually asked to put up 2 months' rent, not just one, but two. They're going to make sure you're interested and that you're there. That's what's kind of hard for that first rent payment. Look at that, $1,900. But what we're going to figure out is what actually is 1 month's rent here, all right, for Miss Jenna. All right, so let's see how it's going to work. We had a $500 deposit. We want to know what the rent is, all right, for 1 month. So we need to definitely say what R, we're going to let R equal the amount of rent. And we're going to pay $500. That's not the rent, right? So we're not going to multiply it times R. It just happens one time, the deposit. We're going to have 2 months of rent we have to add. So we're going to put 2R in there. And the landlord's saying, you owe me $1,900, all right? Up front, my friends. Welcome to real world math. Right there you are. So what we need to do is get R isolated, all right? And this is the formula. Deposit plus 2 months rent, your first bill to the landlord. Very straightforward, very straightforward. So we're going to subtract 500, both sides here. We're going to work it out algebraically. I know some of you say, I think I can figure that in my head. I hope you can. Now we're going to subtract that 500. We're going to get 1,400 hanging on there. You see where we're going? We're going to divide by 2. This one's very straightforward. Divide by 2. No fractions involved here, are there? And we've got R equaling, looks like $700. That's 1 month's rent. And you're going, Ernie, that just doesn't seem fair. It only should cost me $700 to move in there. It's not the way it works in the real world. I'm sorry. So let's go back and see, did you really have to pay $1,900 if you followed our formula? Well, let's see. Let's check it out. We got 500 plus 2 times 700. Will we get 1,900? Big question there. Money, 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 money. All 3 areas. I got 500. Whew. That 1,400 stings, doesn't it, guys and ladies? Wow, I tell you. Equals 1,900. I'm seeing 1,900. I'm seeing 1,900. I'm seeing a lot of dollars. Unfortunately, it does check, and that's your monthly rent right there. So you got to remember, hey, when you're earning money and coming home and paying it, rent and house payments take a chunk out of it. They take a chunk out of that salary. So give thanks to mom and dad, right? And anyone else who's taking good care of you right now, all right? Now, I understand we've got another great L&N STEM video for me here. All right, let's see what we got.
Hello, I'm Lucas McConnell from the L&N STEM Academy. Hey Mathline, I heard about a junior class selling granola bars. They purchased 1,250 bars and paid a delivery fee of $25. If their total cost was $800, what was the cost of each bar?
Junior class sponsors and all you club sponsors, you're hearing this one. And also you guys who are officers in clubs and classes, oh my goodness, you raise money, right? You do. Everybody raises it. You got to raise it for team. You got to do this, that, and the other. It says here a class purchased 1,250 granola bars. There's a lot of selling going on, babes. And they paid a delivery fee of $25 if their total cost was $800. What was the cost of each bar? Well, let's check it out. Let's put this thing into motion, all right? First of all, we want to know cost, all right? So I'm going to use C. We're going to let C equal the cost per bar. All right, that's what we're looking at here. We know how many bars we bought. We bought 1,250 of them, and we paid some amount. Remember, 1,250C means 1,250 times that cost, all right? And that's what we got. But we also had to get them delivered to us. And since we're nonprofit, because it's a school, it's a math team, right? The math team, there we go. And let's see. Our total bill is $800, all right? Now, first things first, let's see what's happening on this, all right? Very simple. Do we follow what I've just done? There's the basically cost of the granola bars. We have a delivery cost, and our bill that we ran up for our class to have to pay, or our math team here in this case, to have to pay, was $800. So, first thing first, let's go ahead and take care of the delivery cost. Let's get it out of there. And now we're going to actually see what the candy bars cost altogether. 12,050 times C equaling, looks like 775 on the subtraction. Now, hey, it's time for me to go to my trusty calculator over here. Let's do a quick division. And oh, by the way, before we go there, let's see what we're dividing by. Because some of you automatically say, oh, that's smaller than that, so we'll divide that into that. We're going to divide both sides by 12.50 because these aren't going to cost quite $1, all right? They're going to be less than $1 each. So now let's go to the calculator and see what we've got here. And like I said, y'all got yours out at home? Have fun with it. Let's see, 775 divided by 1,250, and we will get a nice cost here of 62 cents, all right? So the cost per bar of granola was 62 cents. Quick check, we always like to do that, make sure we didn't get shortchanged, or maybe we made a good deal, I don't know. Let's see, we got 12.50 times 62 cents, and we're going to add 25, and we're hopefully going to get 800 back. So again, switch off to my calculator for me, guys. Let's see if we can get 800 back out of this thing. Clear out that business. That's what we hope we're going to have. 62 cents hopefully will work. Let's test this thing out. 1250, 1,250, as Lucas said, times 62. Notice that decimal point and notice the time symbol. Now we're going to tack on 25. Yeah, you can do it in one fell swoop. You don't have to do it piece by piece. You can do it all in one swoop. You get 800. All right. And you know what? When we get 800 equal 800, we're happy it checks. All right? So good cost right there. So again, that's a practical application. You say, when do we ever use this algebra? You do it a lot of times. And a lot of times you're just thinking to solve problems that you don't even realize you're going through a process, but you're analyzing and you're working it through, and you're basically working backwards to get to that 62 cents. And the calculator, yes, it helps a little bit. Yes, it does. Yes, it does. So one real quick one here for the road. Let's see if we can look at one more down here on the paper here and get a problem off real quickly. It says amusement park charges $50 for admission and a $10 fee for a vehicle to park. If the total bill was $210 for a big group here, small group actually probably, and if the total bill was $210 and everybody rode together, one car, how many were admitted? All right, so let's look at this. We're going to use A for the admission price. Don't know, right? No, we're not going to use A for the admission price. We're going to use A for how many were admitted. Yes, all right. Want to make sure we're doing the right things. How many admitted, okay? When we get toward the end of the show, we get a little excited, and sometimes we get toward the end of homework, we get excited, right? So it's not the price. We already know the price. So we're going to take, each person paid $50. This is all about the money. So 50A, 50 times 50 admissions, all right, how many admitted, plus 10, and the total bill, whopping $210. It's probably actually underpricing here. I'm probably giving you a sale price on this from some of the amusement parks that I've been to. Now, let's subtract 10 and see where this leads us. It gives me 50A equaling to 200 right over there. I'm going to divide by 50. You're going to divide by 50. And some of you said, I got this in my head. I did it in my head. I'm also excited. So we have 4 people, 4 persons. How many were admitted? 4. All right, that's what our A value is. Quick check. Let's do it. 50 times 4, add 10. You can do this in your head, can't you? I tell you, mental math is a wonderful thing when you got it rocking. So we got 200. We got 10. Do we get 210? Oh, yes, we do. Way to go, all right? And you all got A equals 4 and $210 back also. STEM Academy, thank you so much for being part of our show today, giving us some good questions, and I appreciate you helping us out. Also, if you'd like to do that sometime this fall, hey, give us a call here at Mathline on down the road, not today. But thanks for tuning in with us today. We will be back again tomorrow with some more fun and games here on TN Learn Mathline Summer School. See you then.